Hi, welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about cellular IoT, and I have Paul Donaldson from Truphone and Johan Lofstad from Microchip. Hi guys, do you want to say hello?
Hi everybody, Paul Donaldson from Truphone. I'm responsible for our global partnerships, and that means working with all the big and major semiconductor manufacturers across the world, integrating our cellular global connectivity services with them to hopefully make it simpler for engineers and customers to deploy in the field. Nice to be here today.
And my name is Johan, and I am a application/marketing engineer at Microchip, and I specifically work with bringing our IT products out, specifically for PIC and AVR, our PIC and AVR microcontrollers.
Great, thanks for joining us today, guys. So, just want to set the scene a little bit. So, in terms of users deciding on the right IoT connectivity, what considerations versus applications need to be made?
Yeah, from my perspective, it's all about the application, right? What is the customer trying to achieve? What are they trying to, what insight they're trying to gain from the end product, and where they're trying to send it for processing at the edge of the cloud. But ultimately, if you look across the technologies, it kind of boils down to power consumption, the range or the coverage, and the bandwidth, so how much data they're moving around. And you look at that then across the product life cycle of the product. So if it ends up being, I don't know, something that will be in the ground for 10 years versus a tracker that will be 2 or 3 years and then will be replaced. So I think, and what I've observed in the last 20 plus years of being in the industry is, things are a little bit more blurred when it comes to, what's out there for the applications. Years ago, it was clear that cellular was high data, high bandwidth, 4G coverage, or it was low data and 2G for some tracking applications, right? And, Bluetooth 20 plus years ago was quite simple. It was a, kind of a 10-meter star topology network and so on. And, what I've seen over the last, certainly 5 to 10 years is, LoRaWAN has come in, Bluetooth mesh is now a thing, there's cellular IoT or low power cellular as well. So there's a lot of things that kind of make it a little bit more complex, I guess, for the design engineer to choose. But ultimately, it comes down to simplicity. For me, it's all about making it simple for the customer or engineer to design a product that just connects, right? It just connects. They shouldn't spend too much time thinking about the Bluetooth connection or the cellular connection or the SIM card and so on, because let's be honest, the insights and the software and firmware they're producing is their IP, right? They shouldn't spend time on that. So simplicity is key for me. And also, there's no kind of one size fits all. We speak with a lot of customers, Greg, that say, well, actually, for the soil sensor, LoRaWAN makes sense, but actually for the backhaul, cellular makes sense. So we're seeing a lot of mix of technologies as well that ultimately allows the application to do what it needs to do in the field.
I think, but what you're saying here also with bandwidth and coverage, those are so important when you're doing, for instance, as you said, sensor nodes. The advantage of using cellular here is you have coverage where there is cellular coverage, right? You don't have to build out a network. If you're doing it on Wi-Fi, you have to be somewhere there's Wi-Fi connection. So, and especially also with our solution here with the new IoT board we're launching, using the AVR in that specifically for doing low power. I think especially the new LTM and both AVRT is really well suited for that, just due to the built-in like power saving features in the protocol itself, which is kind of groundbreaking in that regard.
So yeah, some good comments in there, guys. So one of the things you were talking about was looking at different variants for maybe like a mix and match for application, for example. But just talk to me a little bit more about how does cellular IoT compare to, say, LAN or Wi-Fi? And when we obviously hear the term breaking the tether, can you just explain that a little bit more?
Yeah. So I think from the whole phrase cellular IoT, that speaks to me about the newer lower power features. So Johan mentioned LTE-M or Cat-M and narrowband IoT or narrowband. they are both under the umbrella of 4G, right? And they are specifically made from the ground up for low data, low power applications. So when we say about cutting the tether, a perfect example. Let me give you a live example, Greg, of a customer we're speaking to today. It's a street lighting application, and their current setup is they have, I think it's Zigbee in the street lights or some kind of 6LoWPAN mesh locally. They have then this gateway which converts to backhaul cellular. And what they're saying is, well, we don't design the gateway, so it's an extra cost, it's an extra thing to support. We don't want to support it. Our expertise is in the luminaire. Now that we have this kind of slight power constraints on what the luminaires can take, we now have an option with narrowband and LTM where we can connect directly to the lamp with sensors that do CO2 detection and making the streetlights smart. And they can do all that with a single connection, right? Straight to the network. It's already there. The cellular network and the coverage is there today. So, that's what it means to me. Cutting the tether is starting to kind of, direct to end solution connections that are simple. They're covered. It's all part of a standard, the GSMA standard in the world of cellular as well. That's kind of a great example of something that was kind of solved, but was kind of a pain point for the customer. It's an external thing to consider, to buy in, and so on. And now they've designed this sensor node that at the space that you can connect directly to the internet.
I'm hearing a lot about the predictions for growth of cellular. So we're talking it's going to be like 20% of the global IT connections, and also 2G will be gone by 2025. So what are the immediate opportunities, and what does this mean for the cellular landscape?
So I think the way the Microchip have designed the board is for low power, right? The cellular hardware module selection is based on LTM and narrowband, so low power is inherent in there. The microprocessor, again, low power is inherent there. And the network connection from Truphone, also based on LTM narrowband connection, is there as well. And there's a trend now, maybe 3 or 4 years ago, to have kind of 2G as a fallback because of the coverage, and LTM narrowband as the preferred, noting that there's not global coverage yet of LTM and narrowband. And it's rolling out, and it's getting much better, but it's nowhere near 2G and 4G is today. So you've kind of got a situation now for design engineers where they say, well, I'm trying to design a low power solution. Don't really want to rely on 2G as a fallback because that zaps the battery. So it's a low power application that's going to massively impact the product life cycle. From a network sunsetting or turning off perspective, US has already done it. So the major networks in the US have already turned off 2G. Australia is done. From a European perspective, we have a few more years. We have a lot of 2G connections here in the M2M space in Europe, and also a lot more MNOs in Europe, right? So it's more difficult for every MNO to agree to turn off 2G with roaming agreements and so on. So you got this kind of mix where actually, from a technology perspective, 2G's worked fine for 20 plus years. Low data, the cost of the modules is low. So there's a lot of things going for 2G, but as the network's starting to sunset, moving towards 4G and 5G and new types of network, then this design engineer's got this kind of dilemma, okay? With the sunsetting, the cost of modules, low power features of the network, etc. And what's going to really accelerate those connections for me is going to be, again, back to low power. We are now seeing applications that we never saw before, irrigation water sensors, agriculture, the smart street light, all these things are all starting to be available to cellular, which is going to drive a number of connections, Greg, that you mentioned, I think, as well. And when you look at kind of, things like the non-cellular, so LoRaWAN is probably kind of done a really good job of taking that part of the market for a long period of time until cellular kind of sorted itself out. But now it's coming back strong there's 110 narrowband networks across the world and there's 60 LTM networks across the world. And if you look back 3 years, it was a quarter of that. So I think 2G sunsetting and 3G has to be taken into consideration. In Europe, it's 2025, so there's a few more years. But if you're going to design today with an 18-month design cycle and then to roll out, and you want a low-power solution, then we're seeing a lot more module manufacturers and partners like Microchip then putting together a truly from from the ground up low power solution, because LTM will ultimately, be the replacement for 2G.
And it's a good point also you're saying here that Paul, with that the coverage is actually just compared to a couple of years ago is a completely different story, where NB-IoT and LTM is extremely viable for doing these applications. And as you said, this is specifically with low power. So what we're releasing is called the AVRT Cellular Mini, just to give the board a name. It's a development board from us here at Microchip that is tailored to make these low power IT applications. And one of the things we've made sure there is to build the actual hardware, the development board for low power from the absolute ground up. So that is not only the module that we selected and the microcontroller, the host MCU that controls the module, but it's everything from having the correct power supply on the board to having the possibility to turn off all the sensors on the board, everything that you can actually use this board as a kind of best practices and as a standalone product if you'd like that as well. So one of the neat things we have with the board is it's actually compatible with the Arduino, and we're releasing a library with that with the board for the Arduino version. The low power is just built in straight from it. You can just do a board.sleep and it'll do all of this for you. Obviously, if you want to dig deeper in the code, it's there. But we're trying to, again, make this prototyping as simple as possible, that you don't have to be an expert on cellular IoT. You don't have to be an expert on microcontrollers. You don't have to be an expert on power design in order to do a sensor node design or any other design that requires cellular IoT with low power. So it can run on a battery, basically.
And I think, Greg, to complement, the kind of the low power theme, we talked about LTM and narrowband, but features of those networks are this power saving modes that we have on the network side, right, where we can essentially, put things to sleep and wake them up in a defined manner. So kind of what from Truphone's perspective, what we do is coverage. We need to have, certainly for your European customers, we've got pretty much most countries now have access to LTM and narrowband IoT. US coverage there as well. So that's important. Equally as important, of course, is giving Microchip's customers, your customers, access to the power save features of the network, because low power and security has to be through the whole chain, right? It starts with the components, all the way through to the network and back again, from choice of protocol, all the way through to the cloud, etc. And if you design part of it for low power but not the network piece of it, then that lets the whole kind of solution down. So, from Truphone's perspective, a couple of things. One, coverage. We have excellent coverage for LTM and narrowband. Two, the power save features of the network we have. And there's some inherent complexities with that, there's which we know and we've tested and we can support customers with if they want to deploy with a power save feature network. And the third thing, and one of the most important things, is that we always thoroughly test with the partners. So we've taken the AVR cellular mini board into our design center in Lisbon and tested it, right, with LTM, with narrowband networks, to iron out any of those creases that could potentially happen. So, and why the Microchip solution is great is that they've thought about low power and security from the start. And so have we. And it hasn't been an afterthought that, we need a SIM card. It's been on both sides, considered decisions on how we support low power and security from edge all the way to cloud.
Great. There's definitely a couple of points in there. I think we will come back to. I'll come back to maybe the low power and security in a moment. But one of the things that you mentioned, Johan, was about making this easy. So, from an IoT perspective, one of the things around hesitancy has been, how do I actually deploy for IoT? So in terms of making this as easy as, say, Bluetooth and Wi-Fi, how will that remove user hesitancy? But also just bring into the answer a little bit more about the partnership and the offering between Microchip and Truphone.
So basically what we've done here is when you buy the board, you'll also get a SIM card from Truphone. And correct me if I'm wrong here, Paul, but I believe it's 150 megabytes for 3 months, right?
Correct.
And we've also, again, built the entire, when you get the board, you connect it to to your computer, and you'll get a landing page. And it's basically this landing page walks you through everything you need to do to actually get started. If that's everything from upgrading the actual firmware on the board, activating the SIM card with Truphone, because you also have to do that. Check the coverage, make sure you have a coverage there. And also we have added a lot of debug output from the board to tell you, oh yes, we're trying to connect, but there's something wrong here, so on and so forth. So without actually even touching any code, you can actually verify that yes, this board is actually connected to the internet. And there's two sensors on the board. It's one is an RGB light sensor, and one is a temperature sensor. And you can actually verify that your actual board is connected by seeing a live plot of those two sensors. But that's just half the story, though. That's okay. Sure, you've connected it to the Microchip sandbox, as we call it, like our AWS setup. But maybe you want to connect it to let's say you want to use AWS. Again, looping back into security. It's so important that your edge node is secured. So we have a chip on there called the ECC608. It's a secure element. And basically what it does is stores keys in cryptographic keys in a very, very secure manner. And we also have a tool called the IT provisioning tool. So all you have to do then is to run said IT provisioning tool. It'll then communicate with the ECC chip on the board, store these keys in a safe manner, and then pair that up with your own AWS account to make sure that all the certificates and all of the handshaking is done correctly.
Great. That was one of the things we were going to talk about, obviously, was security power. But the other point of the conversation, I think, would be scalability as well.
Sure. Yep.
So in terms of IoT developments, what's the approach to that with this partnership as well?
Go ahead, Paul.
Yeah, I was going to say, from our perspective, one of the things that Truphone does is that we're a maker and not an integrator. And we'll come on to it maybe later, Greg, but we base our technology on eSIM, so the ability to reprogram over the air what the SIM is doing, right? What networks it connects to, LTM or 4G, what it does when it lands. And we can do all that over the air. So that helps us a lot with flexibility and scalability, because in the world of IoT, not everyone has, yes, we'll do 10,000 a year every year, and it's a fire alarm panel, and it's very predictable. What we find is, well, actually, we're going to design it in the UK, we need to end of line test it in China, and it's going to be deployed in the US. But we don't want to activate the SIM because we don't want to be charged the data plan, and so it activates in the field, for example. Very common thing to happen in IoT. Or, well, if it goes well, it'll be 100,000, but actually we're starting with 1,000. So how do we commercially and technically support that as a project, right? So, and we have different ways of doing that. We have things called footprints, and footprints are things like basically where and how it will connect geographically and to what networks, for example. And we have kind of commercial proposals built on, well, from SIM1, pay-as-you-go or pay-as-you-grow plans, for example. If the customer has cash flow issues, then they can do a monthly paid plan. Or if they want to ship the product with 5 years of 10 years of connectivity out of the box, we have a prepaid plan. So, whatever the business model and whatever the application, I've probably seen it. And, having that kind of in-house maker mentality means I can tweak and adjust to anything that the customer needs, whether it be a startup, not sure, or high volume, low data, or networks where LTM, for example, I had a customer this week. We're going to deploy in Europe on LTM, but in the future we might go into the US, right? Well, that's okay, because we can, the footprint we have can also extend to the US without swapping SIM cards out, without you having to change things yourself, Mr. Customer. A lot of it is OTA, right, over the air. So that, I think, scalability and flexibility, kind of, Greg, for me, are like the cornerstones of any IoT project, and that's what from our perspective, what we bring to the table.
And also from a hardware side, the reason I also brought up the ECC here is you need some way to uniquely identify the device you're adding. So, for instance, a lot of our customers use AWS to do their fleet management, and in how one of the ways to activate your device in AWS is something called just-in-time registration. So basically, what that is as soon as a one of your devices tries to connect to your specific network in AWS, if it has a certificate that is signed by a root certificate that you have chosen, this is basically how HTTPS web certificates work. It's the exact same thing, X509, I believe. Then it's automatically added to the rest of the system and is giving the correct policy and permissions depending on how it was signed. So what we offer from Microchip is when you buy this ECC 608 from the factory, you can have them already signed by a certificate. We have both something called Trust and Flex and Trust and Go, so you can read more about that on our website. But basically, that is again back to the scalability, and that you just make sure that your devices are signed by the right certificates, or you can get the individual certificates for the boards themselves, and you add it to your AWS account, and you don't have to manually add every device as you go along. So it's easy to scale in that way.
Great. So just in terms of SIM technology, then, if you could just explain a little bit more around how that technology is then sort of like enabling the charge towards IoT, for example. Could you just explain a little bit more on that? Because it might be something that a lot of people are maybe slightly unfamiliar with.
Yes, sure, Greg. This is a huge topic, right? But I think that the headlines are that we're all very familiar with micro, mini, nano plastic SIMs, right? Very familiar in the IoT space and the consumer space. But led by Apple in 2019 and Truphone, eSIM, the ability to choose networks, reprogram networks over the air, so removing the need to physically take a Vodafone SIM out and put a Deutsche Telekom SIM in. That kind of eSIM, what was a revolution, is more like an evolution now, right? If you look at the number of eSIM connections, look at the number of module manufacturers adopting that technology, it makes a lot of sense for the end design engineer. And if you think of it as a form factor independent technology, if you like, so if you could have this reprogrammable over-the-air flexible technology on a plastic SIM, but actually what design engineers want to do is either solder something down or ideally have no SIM at all, right? So what we're finding now with a lot of our IoT customers is, well, I want to solder down a MFF2 SIM, right? Because it's part of the reflow solder process, it's more inherently secure, but if I do that, then I'm locked in, right? I'm locked into the vendor. And that's where eSIM technology comes in, right? You can make the move from plastic to chip SIM in the short term. Today, they already have deployments. That means that there's over-the-air flexibility. You can steer the SIM, you can access the SIM, what it does, etc., etc. And also you're future-proofed, right? If you have an eSIM compliant solution like Truphone, GSMA compliant, then there's the ability to not be locked into a vendor going forward, right? So that's the first step. And we're seeing module manufacturers now already, probably the last 18 months, taking kind of chip scale package eSIMs, integrating them into modules, and then having a single SKU, right? But there's still a physical SIM element there, but it's no longer an additional component on the board. And now we're seeing module manufacturers moving to something called iSIM. And kind of iSIM really takes away the physical part of the SIM, right? It's basically going to be a separate or dedicated silicon area which sits alongside the application processor or the cellular radio. And again, that just means more integration, lower power, lower cost, single SKU, and also for purchasing, for the purchasing guys out there trying to buy components, they're having to work out data plans and SIM cards. We find that being, problematic for CEMs buying on behalf of OEMs. Whereas if you bought a module which comes with a data plan and the SKU is ABC, then actually that's going to be a lot easier on the commercial side. So you kind of, eSIM's more an evolution, iSIM's an evolution as well. Both are kind of here today. eSIM is, Truphone has about 20 million connections now based on eSIM, and following the consumer trend of smartphones and into M2M, that's already happening. We've got deployments at scale with technology. So we're going to find that, the microchips, the Sequans, and the Truphones will start to blend, more and more into one or even two chip solutions. That can only help the end design engineer, Greg, from my perspective.
Yeah, absolutely. I think what you're saying there, it definitely sounds like there's less complexity, but there's more advantage. You're talking about in terms of low power and security, but then actually removing any of those kind of offshoots on the complexity. Yeah, so thanks for sharing that, Paul. There's a lot of good information in there.
Yeah, I think just to conclude on that piece as well, you know, back to the microchip board and the low power module and low power design they've done. You know, the great thing about, I think Johan mentioned at the start of the call, was cellular's everywhere, right? And as we deploy in our kind of world of mobile network operators, more access to LTM and narrowband under the 4G umbrella, well, that's the prerequisite to 5G as well, right? So that will move forward into an already part of the 5G standard for, you know, mass IoT. And that's, again, another accelerator towards more connections. And to your point, Greg, that there's X billion connections by whatever year it was. That's part of it, right? So it's very much, it's ubiquitous, it's everywhere. And, you know, we have a solution with Microchip that kind of ticks most of the boxes, and it'll move forward into the 5G domain as well.
Great. Johan, from you, is there any other additional points that you would want to make before we start to close off?
Not on specifically. We were talking about SIM cards itself. I think that's where Paul is the expert. But I can just mention that we have on the actual board, you have the traditional plastic SIM connection, and that's what we're bundling with the package. You'll get this plastic SIM, but we also have a footprint if you want. What do you call it? Like a
yeah, it's MFF2 kind of stuff. It's like a QFN package, you would call it, Johan, I think,
yeah, right? Exactly. Yeah, that you can just. So that's just, we only have the footprint of that. You have to solder it out on yourself, but it should be fully integrated if you want to go ahead with it on the board.
Great. Yeah, and I think for evaluation, Greg, plastic is fine, right? You want to plug it in and do it. But the fact that Microchip have got the solderable bit on there, you can absolutely get or request some additional trial SIMs from Truphone and solder them on and try them, right?
And also the good thing about the board that we're releasing, it's you can just go to our product page for the board and you'll find the LTM schematics files. So there's also some licensing terms, obviously, but if you want to use this board as a reference design, which is basically what we're trying to make here, is just get it as easy as possible to get started with your RT design. You can go ahead, just you can find the schematics on our website.
And I think as part of the kind of the kind of documentation, Johan, right? We have links to truphone.com for the latest LTM and narrowband networks and so on like this, right?
Yeah, exactly.
We'll definitely put obviously those links, etc., below this video as well for users to come and look on your site to get as much information as they need. And also, I think we're going to be doing some more activity around the board itself. So, yeah, just in closing, I really thank you for your time today and taking us through the world of cellular IoT. And in terms of the partnership between Microchip and Truphone, it's definitely an exciting thing that we were happy for you guys to come and discuss with us today.
Yeah, it's been a pleasure, Greg. I think trying to make cellular IoT simple is kind of why we exist, and the more we as manufacturers and work together with Microchip and some of the key leaders, then that will have a knock-on effect positively for our SSN customers, right?
Yeah, I think that's a good way to conclude on that as well. Like, if you're gonna make a very good IT application, you have to work on all levels, from the lowest silicon to the highest cloud computing, right? You have to look in the entire chain.
Absolutely. Guys, thanks for your time today, and I hope we can talk to you again on Design Spark sometime soon.
Thank you.
Thanks, Greg. Thanks, Johan.